Question 1. The speed of sound in air is measured to be 343 plus or minus 5 meters per second at room temperature, which is 20 degrees Celsius. Which of the following statements is correct? This question tests our understanding of the difference between accuracy and precision in experimental measurements. So what do we already know? We know that a measurement is considered accurate if the accepted or true value lies within the uncertainty range of the measured value. Precision, on the other hand, is judged by the size of the uncertainty. A smaller uncertainty indicates higher precision, while a larger uncertainty indicates lower precision. We also know that the accepted value for the speed of sound in air at 20 degrees Celsius is approximately 343 meters per second, assuming dry air at standard atmospheric pressure. Now let's work through the reasoning step by step. First, we look at the measured value given in the question. The measurement is 343 plus or minus 5 meters per second. This means the measured value is 343 meters per second, with an uncertainty of 5 meters per second. From this uncertainty, we can determine the possible range of values for the measurement. The lowest possible value is 343 minus 5, which gives 338 meters per second. The highest possible value is 343 plus 5, which gives 348 meters per second. So the uncertainty range of the measurement is from 338 to 348 meters per second. Next, we compare this range with the accepted value. The accepted value for the speed of sound at 20 degrees Celsius is approximately 343 meters per second. We now check whether this accepted value lies within the uncertainty range. Since 343 lies between 338 and 348, the accepted value is indeed inside the measured range. Therefore, the measurement is accurate. Now we consider the precision of the measurement. Precision depends on how large the uncertainty is relative to the measured value. To assess this, we calculate the relative uncertainty. The relative uncertainty is the absolute uncertainty divided by the measured value. So this becomes 5 divided by 343. Evaluating this gives approximately 0.015, which corresponds to about 1.5%. An uncertainty of about 1.5% is reasonably small for many experimental measurements. This indicates that the measurement is fairly precise. Since the accepted value lies within the uncertainty range, the measurement is accurate. And since the uncertainty is relatively small, the measurement is also reasonably precise. Therefore, the correct statement is that the value is both precise and accurate. This is our final answer. What did we do? First, we interpreted the measured value and its uncertainty to determine the possible range of values. Then we checked whether the accepted value for the speed of sound lies within that range to determine if the measurement is accurate. Next, we evaluated the size of the uncertainty relative to the measured value to judge the precision. Finally, we concluded that the measurement is both accurate and reasonably precise. To summarize the key ideas, precision is determined by the size of the uncertainty. A large spread in the measurement range indicates low precision, while a small uncertainty indicates higher precision. Accuracy refers to how close a measured value is to the true value. If the accepted value lies within the uncertainty range of the measurement is considered accurate,